You made it. Last section of Algebra 2. This is it right here, the last one. This is called Making Inferences from Experiments. So just like last section, we're making inferences, we're having our data, and we're making conclusions, drawing conclusions from that data. But in this case, the data is coming directly from an experiment, which actually makes it a little bit, better. So since that thing comes from an experiment, it comes from your information, that's going to make it much, much, much more accurate. Okay? So now what we're going to see is really examples. I'm going to work through an example with you. I'm going to go through all of the questions from that example, and then hopefully that's going to be pretty straightforward. There's 3 examples in this section. Starts on page 634. If you have any questions, shoot them at me so that I can see them. But basically what we're looking at right now is this. We are looking at a farmer has planted 10 plants in a treatment group, which the treatment group receives the soil supplement, and then he's planted 10 plants in a controlled supplement or controlled group, which that control group doesn't have an extra soil supplement. Okay, so he's planted 10 plants. These are the 10 plants. This is how much he actually got from each tomato plant. Okay, so the control group is the one with just soil, and the treatment group is the one that receives an extra soil supplement. So now, basically, what it's saying for part A is it's asking us to find the mean yield. So we want to find the mean for the control group. Okay, when you find the mean for the control group, that just means you add all of the numbers together and divide it by the total number of things that you have. And in this case, when you add them all together, you get 13.7. Divide them by 10, and you get 1.37. So that means the average plant yielded 1.7 kilograms of tomatoes. All right. For part B, it's asking us to find the average of the treatment group. So when we find the average of the treatment group, when you add everything together, you get 16.9 over 10, and that gives us 1.69. So there's 1.69. Now right away, I can see that from 10 plants, I can see that the treatment group actually responded better than the control group did. Now that doesn't mean necessarily that it works. That could just be correlation. It could just be because he didn't actually do a whole lot of testing. But right now I can at least draw somewhat of a conclusion that this is going to be, bigger. So part C says find the experimental difference of the means, which basically just means I take the mean of the treatment and I subtract it from the mean of the control. So I take the mean of the treatment minus the mean of the control, and when I do that I get 1.69 minus 1.37, which tells me that the difference is 0.32. Now if that mean is positive, then that automatically means right now that I've done everything that I needed to do. I'm done. That gives me my, that shows me that that information is good. Now, the big part, the thing that you have to kind of pay attention to, and this is the part that makes things kind of tricky, is we have to make sure that this is not just because of an outlier. Now, I can increase the mean of something significantly by having a really big number, right? Like if one of my plants yielded 40 kilograms of tomatoes and everything else yielded 1 or 0, whatever, that's going to increase my mean significantly, right? If I had 9 plants that yielded 0 and 1 plant that yielded 40, 0 plus 40 is 40, divided by 10 is 4, all of a sudden now I've got an average of 4, but that's not right because one of my things was an outlier. So the way that you can kind of work through this is you can then go through a scatter plot, or a double plot. So what I'm going to do is I'm actually going to create 2 plots so that I can compare these 2 numbers. They're going to be on the same exact scale, and that scale is going to go all the way from 0.7 all the way up to 2.1. Actually, it should go to 2.4. But I'm going to have 0.7, I'm going to have 0.8, 0.9, 1, 1.1, 1.2, 1.3, 1.4, 1.5, I'm going to run out of room, 1.6, 1.7, 1.8. I'm just probably going to end up going to 2. 1.9 and then 2. Okay? Now, looking up at this graph, there's only, one value that goes higher than 2, and that's this 2.4, so we'll just kind of pay attention to that. So there's only one value there. But I'm going to put the same exact marks down here because what I'm going to do is I'm going to compare my data. Now, when I compare this data, I'm basically just going to go through I'm basically just going to go through and put dots wherever the data is supposed to be, and I'm going to compare the difference between the data points. Okay? So when I look through, I can see, I'm going to do the top one first. I had a dot at 0.7, 1 at 0.9, 2 at 1.2, I had two things at 1.2, 1 at 1.3, 2 at 1.4, 1 at 1.7, 1.9, and 2.0. So it looks like this. Okay. Now when I do the other one, I have 1 at 0.9, I have 1 at 1.4, 1.5, 1.6, 1.7, 2 at 1.8, 2 at 1.9, and then there's going to be that 1 at 2.4 that's going to be way out there. Okay. Now when you look at this, it's not like this has any outliers. Actually, if I was going to suggest anything or look at anything, I would say that most of my points are actually pretty well represented, right? They're represented right in that middle. I've got an outlier kind of out here and an outlier kind of up here, but for the most part, most of my information is pretty well, well gathered together. If you look up at the graph above it, that one's actually not represented very well at all, because that one has all the way from 0.7 all the way up to 2, and then only a few things scattered in between. So I would say that the treatment group is actually more consistent as well. So not only is it more consistent, but it also produces a bigger yield, which then I can say this is a very, very good experiment. This is a very good yield for this thing. Okay? So the last question says, what can I conclude? My conclusions would be that the treatment group provided a more how do I want to say this? The treatment group provided a more consistent yield because more plants responded in a very close knit from 1.4 to 1.9 yield. I would also say that it had a higher average yield, so I would say the treatment group works. I would also protect myself by saying this could just be by chance that this happened because the sample group is small. We only tested 10 plants, so I would like to follow this up with an experiment where we test more plants. Okay? That's what I would do for this. That's what I would do for this type of question. Now there are two other examples that work through very, very similar things for this. You can make your own inferences, but this is basically what 11.6 is all about. Okay? There is one other thing on here. It's called resampling. We are not going to go through resampling because it's pretty complicated, so don't worry about resampling anything. You can look through the example in your book, but it's not something that I'm really super concerned with. It's not something that I'm going to work my way through, so don't worry about it. Okay? That's it, folks. That is the end of Algebra 2. If you have questions, ask them to me. Okay? Make sure that I know what is going on. Make sure you keep in touch with me. Make sure that I don't have to hound you too much to actually complete these things, because I would hate to see you back next year because you were too lazy to actually do anything at the beginning. Alright? So, talk to me. Ask me questions. Check in with me. If you want to just talk and chat, send me an email, send me your mind, and let me know how things are going. I would love to hear from you. I'm kind of bummed. This is the first year I haven't been able to actually say goodbye to you guys and face to face. So it's been a pleasure working with you guys this year. Please make sure that you let me know if you have any questions. All right? Have a good one. Good luck with everything you're doing.